Why does my room smell like cum? Huh?
1982, there was one SAT question that every single student got wrong. Here it is. In the figure above, the radius of circle A is 1/3 the radius.
What is it? Hold on. I have my brain. Hold up.
In 1982, there was one SAT question that every single student got wrong. Here it is. In the figure above, the
Close in chat. Close chat, promise.
The radius of circle A is 1/3 the radius of circle B.
Okay. In figure above, the radius of A is 1/3 of the radius of B.
Yeah. Come on. Keep going, bruh.
Okay, in French, this is hard because in French, isn't this, whatever. I got this.
Circle A rolls.
Yeah.
What the fuck?
Wait, what? Circle A?
At the end of how many revolutions of circle A will the center of the circle first reach its starting point?
Okay. See? 1/3. So the circumference of B is, let's say B has a radius of x, right? It's 2 pi x, right? Then the circumference of circle A is 2/3 pi x. So then the wait. So to do a third. So to go like this. The third. Should be 3 then. No? 3?
Wait, what the fuck? What the fuck?
Wait. 1, 2, 3. Should be 3.
Ow, my head, fuck!
Why not 3?
Starting
Probably some...
and showing in figure. Circle A rolls around circle B. At the end of how many revolutions of circle A,
The chat is
will the
saying
center
4.
of circle first reach its starting point? Will the center of circle...
Wait. It should be just 3. Chat is saying 4. Why 4?
reach its starting point? Hold on. So the way to go about this is to like a ribbon. To really break it down, you have to think it like a ribbon. So A would be now unfolding like a like, and it would go. Okay, and 3 times, just 3 times. That's it. Just 3 times. Just 3 times.
should be
rolls
just
around.
3, right?
He
But why is
rolls
just saying
around.
4?
So
No, because you have used formula. You have A has a circumference of 2 over 3 pi. Then B has a circumference of 2 pi times the radius. But the radius is irrelevant. Pi is irrelevant because it's a common factor. So then it will be obviously a third. The circumference of A will be a third of B. So one revolution will get A third, and one B, another one. So when it's 2, get 2/3, and that third one will get it back. Right?
Is it A, 3 halves, B, 3, C, 6, D, 9 halves, or E, 9?
Then it should be.
oh no 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 no
Which
no
I
no.
don't know what revolution is, but I think revolution is just it going 360 degrees once, right? It's like a wheel. It go if you have a wheel like this, a circle, and you have a point on the bottom, right? A point on the bottom. Then a revolution is when it goes like this, like one full rotation. So then it should be 3. If it's B, then
Hold up.
and chat is saying E for no fucking reason, dude. They're trolling me.
It might just be 9. It might just be 9. It's multiplicative. It multiplies because
Wait. Wait, maybe he's cooking because maybe if it's like both of them can rotate, you get that A rotates and then B rotates the other way, right? So you get this, like two cogs. Then, since both of them will make a rotation, they will make half the rotation, right? So an A would only make half of the way it would have if B was static. So then it would be 9, because you get 1, 2, 3, 4, 5, 6, 7, 8. Wait, 1, 2. Let me think. And because B is 3 times bigger, so then it would only make a third of B's whole radius. Then you get 1, 2, 3, 4, 5, 6, 7, 8, 9. Maybe. Depends on if B is static or not.
SAT questions are designed to be quick. This exam gave students 30 minutes to solve 25 problems, so about a minute each. So feel free to pause the video here and try to solve it. What is your answer?
it's 2. It's B.
I'll tell you right now
I
that
should say
option
B.
B or 3 is not correct.
Well, and I
That is
think
9.
I think you're kind of annoying. And I think this video sucks.
When I first saw this problem, my intuitive answer was B, because the circumference of a circle is just 2 pi r, and since the radius of circle B is 3 times the radius of circle A,
I
the
thought about doing
circumference
this
of circle
pi
B
to
must also be
everything.
3 times the circumference of circle A. So logically, it should take 3 full rotations of circle A to roll around circle B. So my answer was 3.
Right.
This is wrong. But so are answers A, C, D, and E.
Then it's, yeah.
The reason no one got question 17 correct is that the test writers themselves got it wrong. they also thought the answer was 3. So the actual correct answer was not listed as an option on the test.
Gigabrain stuff.
Because it's some bullshit like 0.0 fucking like delta bullshit, like theoretical fucking quantum shit.
Mistakes like this aren't supposed to happen on the SAT. For decades, it was the one exam every student had to take to go to college in the US. It had a reputation for determining people's entire futures. As a newspaper from the time stated, if you mess up on your...
Because the first roll is free.
SAT tests, you can forget it. Your life as a productive citizen is over. Hang it up, son. Of 300,000 test takers, just 3 students wrote about the error to the College Board, the company that administers the SAT. Shivan Kartha, Bruce Taub, and Doug Youngrice.
I did a lot of math problems when I was young. For the competitions, I probably did thousands of math problems. I read it, and I was amazed how badly it's worded. I just put 3 down. I figured that's what they wanted.
The 3 students were confident none of the listed answers were correct, and their letters showed it. As a director at the testing service recalled, they didn't say they had come up with possible alternative answers or that maybe we were wrong. They said flat out, "You're wrong," and they proved it.
I discussed it with some other people and said, I think there was a mistake, and they mostly said, no one cares. I wrote a letter to the educational testing service. It was a little while later. They called us and said, I was correct.
Here is their argument. The simplest version of this problem is with 2 identical coins. These have the exact same circumference. So by our initial logic, this coin should rotate exactly once as it rolls around the other. So let's try it. Okay.
Well, I mean, at least put something on it so I can see it.
But wait, we can see it's already right side up at the halfway point.
Wait, I was
so
right there.
if we finish rolling it around the other coin, it'll have rotated not once, but twice. Even though the coins are the exact same size. There are no tricks here. You can try it for yourself, and I'll do it again slowly. It's 1.
Wait, I did that.
2. This is known as the coin rotation paradox. This paradox also applies to question 17. I've made a 2-scale model of the problem. One useful tip for standardized tests, even though they say their images are not to scale, they almost always are. So when we roll circle A around circle B, we can see that it rotates once, twice.
He was wrong.
3 times, and 4 times in total. So the correct answer to the...
I said 4 because you get a free roll. I said that. I said that. I said that.
This question is actually 4. Once again, the circle rotates 1 more time than we expected. To understand this, let's wrap this larger circle in some ribbon.
I bet the chat. everyone just said something different. Even chat wasn't agreeing. Chat, look, go back into the VOD. Everybody was, you get a free roll.
He said 3.
And I'll make it the same length as the circumference. And then I will stick it down to the table as a straight line. I'm adding some paper here, so there's something for this to roll on. And now it rolls 1, 2.
The ribbon. He even did the ribbon. Look, he even did the ribbon. Look.
3 times. What's happening when we turn this straight path into a circular one is that circle A is now rolling the length of the circumference and it's going around a circle. The shape of the circular path itself makes circle A do an additional rotation to return to its starting point. So this is the general...
An additional rotation to go over the starting point. A free roll. Dude, chat, I'm some sort of fucking genius, I swear. Chat, ow, hold up. Oh my God. Chat, my brain is expanded and I think chat.
General solution to the problem. Find the ratio between the circumferences of circle B and circle A, and then add 1 rotation to account for the circular path traveled.
But there is a way to correctly get 3. Let's count the rotations of circle A from the perspective of circle B looking out at A. We can see circle A rotates 1, 2,
Yep.
3 times. And
3
it doesn't
times.
matter which circle you are looking from. To circle A, it also rotates 3 times to come back to its starting position around circle B. Similarly, from the perspective of the coins, we can see that the outer coin only rotates once as it rolls around the inner coin.
Yep, so 3.
Using the perspective of a circle is just like turning the circle's circumference into a straight line.
What? I'm almost choked on that shit.
It's only as external observers that we actually see the outer circle travel a circular path back to its starting point, giving us the 1 extra rotation.
But there's even another answer.
If you look closely at question 17, it asks how many revolutions circle A makes as it rolls around circle B back to its starting point. Now, in astronomy, the definition of a revolution is precise. It's a complete orbit around another body. The Earth revolves around the Sun, which is different from it rotating about its axis. So by the astronomical definition of a revolution, circle A only revolves around circle B once. It goes around 1 time.
But with the question on hand, though, that creates a paradox. Because it has to roll.
And it's 3 times the revolutions because of the length and 1 because of the orbit.
Wait, it creates a paradox by default.
Now, other definitions of a revolution do include the motion of an object rotating about its own axis. So 1 isn't a definitive answer, but the wording of this question is extremely ambiguous if you can justify at least 3 different solutions.
After reviewing the letters from the students, the College Board publicly admitted their mistake a few weeks later and nullified the question for all test takers.
They said they were discounting the problem and they were calling us because they were going to tell.
Also, it's not good enough, chat. Guys, academically, it's not enough to just remove the question. People should be given a cushion, a little bit extra points overall.
Guys, I'm the big brain one. I said that the revolution wording is fake. So I'm the big brain one.
For free on their tests because of the mental impact of momentum loss on an exam when you hit a hard rock and it makes you read about everything, and there's a definitive psychological impact on an entire test when you have a flawed question like that. It is what it is.
They said they were discounting the problem and they were calling us because they were going to tell the news and they thought that we should be warned that the news might contact us. I did a bunch of phone interviews and NBC News. They came to my school They said I was right, and they were discounting it, so that was great.
But there's more to the explanation.
It's easy to get an intuitive reason, but it's really hard to formally prove that the answer is 4. I could give you some proofs if you want.
Well, that would be wonderful. I think that would be, we'd appreciate that for sure.
I have a whiteboard because I'm a mathematician, so I just happen to have a whiteboard here. Hold on. Can you see that?
Yep.
It turns out that the amount the small circle rotates is always the same as the distance the center travels. All right, so why is this true? Suppose you had a camera and the camera was always pointed at the center. So in your movie, it looks like the center doesn't move. In the real world, the center is going around the circle. Let's say it's going at some speed v. What's the velocity of this point? It's 0. And that's because it's rolling without slipping. If it had any component in that direction, that's what slipping would be. I mean, this is something I think they should have spelled out in the problem, but when you change your frame of reference, the relative velocities don't change. In the movie, the center always has velocity 0. So this point would have to have velocity -v.
Well, that's a physics problem.
So that means the speed that this is turning is the same as the speed the center is moving. So if they always have the same speed, they have to go the same total distance. The total distance this turns has to be the same as the total distance the center moves. In this problem, the center of the small circle goes around a circle of radius 4. So the total distance that the center moves is 8 pi. What's the total amount that the small circle rotates? It rotates 4 times, and its circumference is 2 pi. It's the same number. If it rolls without slipping, the total distance the center travels is the same as the total amount it turns.
And this is always true. Take a circle rolling without slipping on any surface, from a polygon to a blob, on the outside or the inside. The distance traveled by the center of the circle is equal to the amount the circle has rotated. So just find this distance and divide it by the circle's circumference to get how many rotations it's made.
Chat, isn't that what cars have to do though? Let's say when they're doing like a car test on one of those like conveyor belts, and they go, right? The thing rolls on the ground, but the wheels are rolling and shit like that.
This is an even more general solution than our answer to the coin paradox, where we just took our expected answer, which we'll call n, and added 1, and it reveals where this shortcut comes from. If a circle is rolling continuously around a shape, the circle's center goes around the outside, increasing its distance traveled by exactly 1 circumference of the circle. So the distance traveled by the circle's center is just the perimeter of the shape plus the circle's circumference. When we ultimately divide this by the circle's circumference to get the total number of rotations, we get n plus 1. If a circle is rolling continuously within a shape, the distance traveled by the circle's center...
And you get a free roll. Chat, why did my brain get there on its own?
Guys, why does he pretend that he knew?
As soon as I
just
said
it.
Decreases by 1 circumference of the circle, making the total number of rotations n minus 1. If the circle is rolling along a flat line, the distance traveled by the circle's center is equal to the length of the line, which divided by the circle's circumference is just n.
I'm actually impressed.
This general principle extends far beyond a mathematical fun fact. In fact, it's essential in astronomy for accurate timekeeping.
When we count 365 days going by in a year, 365.24 to be precise, we say we're just counting how many rotations the Earth makes in one orbit around the Sun. But it's not that simple. All this counting is done from the perspective of you on Earth. To an external observer, they'll see the Earth do 1 extra rotation to account for its circular path around the Sun. So while we count 365.24 days in a year, they count 366.24 days in a year.
This is called a sidereal year. Sidereal meaning with respect to the stars, where an external observer would be. But what happens to that 1 extra day?
A normal solar day is the time it takes the Sun to be directly above you again on Earth. But the Earth isn't just rotating, it's orbiting the Sun at the same time. So in a 24-hour solar day, Earth actually has to rotate more than 360 degrees in order to bring the Sun directly overhead again. But Earth's orbit is negligible to distant stars. To see a star directly overhead again, Earth just needs to rotate
There's no
exactly
way
300.
Nothing happens when you die. Guys, seeing all this, look at all the material, all the things like out there. The system is too complicated for it to be that simple and lame. As you die and there's nothing. It's too complicated.
You got to reboot it.
160 degrees. So while it takes the sun exactly 24 hours to be directly above you again, a star at night takes only 23 hours, 56 minutes, and 4 seconds to be above you again. That's a sidereal day. This explains where the extra day goes in the sidereal year. If we start a solar day and a sidereal day at the same time, we'd see them slowly.
What if we're all just beings, right? And we're all equal, because this is like end game, like we teleport into the future, and we're all even. And we just got bored. Like, dude, we're all even. It's world peace. Everybody's happy. We're all invincible. Why don't we just open up a private server, and everybody gets in on that server, and it's really imbalanced. So people start poor, rich, bad country, hungry, thirsty, third world country. It's how well do you do with what you're given, and it gives you a margin like a rank, and this is the ranked seed. This is the tournament seed, and to see who that start from the bottom. How well do they do, people? That's not the top, and they fuck it, and they lose a lot of points. And this is the rank seed. Think about that.
Fully diverge throughout the year. After 6 months, the sidereal day would be 12 hours ahead of the solar day, meaning that noon would be midnight, and it would keep moving up until it's finally 1 full day ahead of the solar day, at which point a new year and orbit begins. 365.24 days that are each 24 hours long are equal to 366.24 days that are each 23 hours, 56 minutes, and 4 seconds long. So it makes no sense to use sidereal time on Earth because 6 months down the line, day and night would be completely swapped. But equally, it's useless to use solar time while tracking objects in space, because the region you're observing would shift between, say, 10 p.m. one night and 10 p.m. the next night. So instead, astronomers use sidereal time for their telescopes to ensure that they're looking at the same region of space each night. And all geostationary satellites, like those used for communication or navigation, they use sidereal time to keep their orbits locked with the Earth's rotation. So the coin paradox actually explains the difference between how we track time on Earth and how we track time in the universe.
Wait! Chat, you know triangle, chat, and it loses an angle? What if you get something so small? It's all an angle. And when you spin, you do nothing. You're going nowhere. Zero. Actually, you get 1 billion free spins.
The rescoring of the 1982 SAT wasn't all good news. With question 17 scrapped, students' scores were scaled without it, moving their final result up or down by 10 points out of 800. Now, while that doesn't seem like much, some universities and scholarships use
but then the circumference is 0, so you get just 1 revolution.
Strict minimum test score cutoffs. And as one admissions expert put it, there are instances, even if we do not consider them justified, in which 10 points can have an impact on a person's educational opportunities. It might not keep someone out of law school, but it might affect which one he could go to. This mistake didn't only cost points off the exam. According to the testing service, rescoring would cost them over $100,000, money that came out of the pockets of test takers.
Wow.
The question 17 circle problem was far from the last error on the SAT. But errors are likely the least of their concerns these days. I mean, the SAT is slowly becoming a thing of the past. After COVID-19, nearly 80% of undergraduate colleges in the US no longer require any standardized testing. And that 1982 exam, Well, it didn't turn out too badly for some.
How did you do on your math SAT, if I can ask?
I got an 800. Even before that, it was clear I was going to go into math. I did math competitions. I really liked math.
Do you end up writing any math questions these days?
A while back, I wrote problems
800
for a
then?
math competition.
And were you careful with how you wrote them, the wording? And
I hope so. I tried.
It's a max. Yeah, I did not get that in school.
Today's
Didn't
deep
much-
dive on one SAT question proves there's no substitute for hands-on exploration to understand and appreciate the everyday phenomena of our world. But you don't have to observe Earth from space or...
Anyway, it's why I think, chat, you know, chat, the Monty Hall problem, I still think it's wrong. I don't give a fuck saying it.
or make cardboard cutouts to get hands-on with math, science, and cutting-edge tech. In fact, you can do it from anywhere right now with this video's sponsor, Brilliant. And you can get started for free. Just go to brilliant.org/Veritasium. Brilliant will make you a better thinker and problem solver in everything.
I still think it's wrong.
Add.
Anyway, here's the video. This is really nice. This is really nice. Makes good videos. Guys, I actually met this guy in person, but I didn't meet him. I met him from afar, like melee range and medium range. I just didn't go say hello because I was too shy. Also, he looks kind of serious. This is like, this is kind of like this tone on him. It's kind of like, yeah, I'm not.